morning, scholars. This is part 7, review for your final. Okay, so imagine that you are underwater and you are a scuba diver. Kind of funny. Sorry, I'll make the bubbles coming from there. Okay, so you're underwater, you're a scuba diver, you're releasing oxygen bubbles from your mask. And the bubbles do what? Well, you know that they go upward. The question is, why do they go upward? So let me kind of zoom in on one of the bubbles. I'm zooming in. All right, and if we look at the bubble itself, in context, we know that technically the bubble does have mg coming down. And then it has this amazing force pushing up on it when it's underwater. All right, it's not normal force, but when you're underwater, it's actually kind of like the normal force of the water pushing back up on you, and that is your buoyant force going up. The buoyant force is directly related to the amount of water that you are displacing. So I've zoomed in on this bubble. What's interesting also is that you do have pressure around your bubble. And the higher up you get, the less pressure you have on your bubble. So it's conceivable that a bubble this size down here could actually expand to this size closer to the surface. Which of these two bubbles has the highest buoyant force? Okay, so I'll call this one bubble A, and I'll call this one bubble B. Okay, there is your question right now. Will you be surprised to know that B has the greater buoyant force? So let me again kind of draw these. All right, I've zoomed in on them a little bit. Here is bubble A and bubble B. Let me tell you one more time. These are actually the same bubble. It is just down here the pressure is greater, it's more compact. Up here the pressure is less, it expands. This is the same bubble. So the mg for A equals the mg for B. They are the same. These two force vectors are the same, but something changes. Okay. This buoyancy force here is different than the buoyancy force above. And we just said in the previous question, the buoyancy force on this one is higher than the buoyancy force on that one. So I'll go ahead and say the buoyancy force, and then the buoyancy force. They are not equal, it is less. The buoyancy force is related to the volume of the substance that is displaced. Okay, so I'm going to give you another question. The buoyancy force is blank to the volume of the fluid that is displaced. Answer now. The buoyancy force is related to, or I'll even go ahead and say it's proportional to the volume of the fluid that is displaced. It's not equal because volume is not a force. But the buoyancy force is actually equal to the mg, or the weight of the fluid that is displaced. The weight of the fluid, obviously, has to do with the volume of the fluid. The bigger the volume, the greater the buoyancy force. These are the two same amount of gas, but because the pressure is higher here, it's smaller. That means the volume is smaller. That means the buoyancy force is smaller. As it expands, because of the lower pressure, the volume goes up, the buoyancy force goes up. Question: which of these has the higher acceleration? In other words, which one travels to the top faster? Boom. This is your question you're going to answer. Which bubble accelerates greater? Bubble A or bubble B? Let me answer that down here. Which one has the greater acceleration? Well, it must be the one with the greater buoyancy, right? Why? Look at this. Which one has the greater unbalanced forces? B. Because this buoyancy force is much greater than that one. That means the net force is greater. Okay, so this has a greater net force. Here is something that I want you to take away from this lesson. The term fluid is subjective. Many things can be considered a fluid or a medium. Water, hot lava, syrup. Even the air in our atmosphere can be considered a fluid. All right, I hope you take something away from this. Thank you. My gift from me to you.